Lesson 41, Member Function Pointers. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. Member function pointers are like function pointers, except that they point to member functions instead of plain functions. In this code sample, we have a point class with two member functions, L1 and L2. These member functions calculate the distance between 2 points by slightly different methods. Given 2 points in the plane, we will call the difference between the x-coordinates delta x and the difference between the y-coordinates delta y. Then the L1 distance is just the absolute value of delta x plus the absolute value of delta y. The L2 distance is the square root of delta x squared plus delta y squared, and gives the distance along the straight line between 2 points. In the example that we show here, the points are 6, 5, and 2, 2, so that delta x is 4 and delta y is 3. Calculating the L1 distance, we get 4 plus 3 equals 7. The L2 distance is the square root of 4 times 4 plus 3 times 3, which is 5. This is the class. It's pretty simple, just two data members for the coordinates and our two member functions for calculating the L1 and L2 distances. In the main function, we create 2 points. Then we call our L1 and L2 distance functions directly on our first point and pass in the second point as an argument. Next, we make the same calls except that we use a member function pointer. First, we declare the member function pointer here. The syntax is messy, but this says that pfnDistance is a pointer to a member function in the class cPoint that takes a point and returns a double. Notice that the signature of our member function pointer matches that of our member functions L1 and L2. After the declaration, we set our pointer to point to the address of the L1 function. Then we call the L1 function through our function pointer using the .dereference operator, which we write as a period followed by an asterisk. After this, we do the same for the L2 function. Executing the program, we see that the L1 and L2 calculations were performed twice. The first time via the direct member function calls, and the second via the member function pointer. Our second program demonstrates the syntax for arrays of member function pointers and has a simple message class with 3 functions that each output a different message. In our main function, we declare an array of 3 member function pointers and assign them to point to each of our member functions. Finally, we loop over the entries of our array and call each function via the pointers in the array. Executing the program, we see each of our 3 messages outputted. It is worth mentioning that a member function pointer is typed by class, so a member function pointer can only point to member functions of the same class. Also, a member function pointer is different than a plain function pointer, so it can't point to plain functions, and a plain function pointer can't point to member functions either. Our third program demonstrates how to use a member function pointer as a member of a class. Here we have an employee class with a member function pointer that is private. The member function pointer is called WageCalc. Below this, we have 2 wage calculation functions for trainees and experienced employees. These wage functions have the same signature as our pointer, and our pointer will be set to point to one function or the other, depending on whether or not the employee is experienced. The function that we point to is called with the function pointer inside of our function calculateWage. Notice the syntax. Here we use the this pointer. The this pointer refers to the object that called the member function. Since it is a pointer, we use the arrow dereference operator instead of the .dereference operator. Notice that in the constructor, our WageCalc pointer is initialized to point to the trainee wage function. The makeExperience function is used to set the pointer to the experienced wage function. In our main function, we instantiate an employee object. Then we output the wage for this employee for 45 hours of work. Note that this will be calculated with the trainee wage by default. Also, we remark that our this pointer points to our employee object. If we execute our program, we get the calculated wages for 45 hours as a trainee and as an experienced worker. For our last example, we take our previous program, remove the calculateWage function, and make the member function pointer public. Now we can call the member function pointer directly. However, the syntax is messy, as we will see. In our main function, we replace our calls to calculateWage with direct calls to our member function pointer. The syntax requires 2 operators. Notice that the object name is used twice. The The first use tells us which object to use, and the second tells us which object's function pointer to use. So you could specify a different object for the function pointer and the object that it acts on. Executing the program, we get exactly what we had for the previous program. This concludes the lesson.